right, so this is going to walk you through pages 37 to 48. So basically working with trapezoids, primarily kites, but also trapezoids. So page 37, I'm just going to walk you through it. I have my highlighters ready here. So when you look at this planter, right, it's a trapezoidal prism. So what that means is that, right, you have a trapezoid and that face is being kind of transposed, extended, right? So we call those prisms when you have a face and that face continues on to give it depth. But you don't need to worry about that too much. The first question is like, what angle do you need to cut out angle A, right? So you want this angle right here in this corner, okay? So which is this one right here. So what I do is I cut out this right triangle here, and I know that this is 30 here. 2.5 is that little sliver. And right as it is, you can't really use sine law. I guess you could use cosine law to figure out x, but I will just go ahead and use Pythagorean theorem. So I did that, and I rounded it to 4 decimals. This is probably 39 something, but it rounds to 40 or just 104. So now you have a pair, and that pair will allow you to solve for that angle, right? So I go sine of the side I just found, right? So I'm going to make an arrow going to it there. Then sine A over 30, right? Sine A over 30, and I figure out that that angle is 85.24, okay? And now, if you think about it, you have a triangle, so if you have two angles, you can find a third, no problem. So you could find a sliver if they asked for it. What name is the shape ABCD, right? That is an isosceles trapezoid. What angle at D, right? Angle D or ADC. See, I mentioned both, right? ADC is this whole thing, okay? This whole thing, not just the sliver here that's created by that dashed line and the slant, it's the whole thing. So remember, I know that on a trapezoid, right, these two angles here add up to 180. So you go 180 minus the one you just found earlier, right, which is A here, and you subtract that and you get 94.76. And this question was somewhat irrelevant. The next one here, what's the depth? Well, we are given that that's 30 centimeters. You could now technically find the area of just this one face here. So 30 centimeters there. We're just going to leave it at that, okay? Then this on page 38, again, this is just to walk you through. I did some highlighting here. So you've got this kite, and notice that a lot of dimensions are given. And we know that the short diagonal here, which is 40, right? This one bisects here. We know that right away. So I'm kind of walking you through it. It's probably on a test you won't have all of these questions given, but you should be able to answer it. So what are the measures of angle BCE and CBE? Right? So BCE, the pink one here, they want that one, and the green one, right? Both of these. There's a reason why I do that, because we know that this stretch here is 40. If you just focus on this right triangle here, this is 40, and then you split this short diagonal in half, you get another 40. Hey, you should recognize that as isosceles, right? So if you already have a 90 here, you split these two, right, which is 90 in half, you get 45 here. This is actually 45 as well as 45. You got two 45s there, and you notice it's on a right isosceles, so I name that right isosceles and tell you that both angles are 45. If you missed it, you could have still used Pythagorean theorem to figure this out, and then use sine law, and you would still come up with the same answer. Okay, so that answers that. Next, I'm asking you to figure out these two angles, right? So the two highlighted there. guess I can go with orange here on this one. So I kind of just use this to help you out. I provide this, right? So I cut out this right triangle here. I cut it out, and I want that angle there. So right now I'm in the same boat as on the previous page. So I'm going to find x because we've got 2 out of 3 sides. I'm going to use Pythagorean theorem to figure out x. I now have a pair, so I can use sine. And this side I found sine of 90 over that, sine of z, I call it z, right? Just to make it a little bit easier. Over 70, you use sine law, you find 60.26, okay? So you have a lot of information now. We know that these are 45s here, up here, so you can kind of combine this and this to get this whole angle. So we have a lot of information there. What is it asking for next? I ran out of highlighters. What's the measure of BCD and BAD? So basically, they're asking for these two here. Okay. So I'm gonna add the 45, which is here, right? This is a 45, is established by what I did in A. Okay. And this 40 is just saying that this side is the same as centimeters, right? It's a bit busy, but 45 plus this plus a 60.26 here. So maybe I'll just follow through with my highlighting, right? So this angle, right, I add that to, it would essentially be the pink, right? The pink angle that I found up here, this one, that pink, which is the same on this side, right? These are the same essentially. So the pink can go here and can go here, whatever you use up there, right? If I add up the 45 and the one I just found up here, those two combined give me that angle that I'm after, right? And these are the same. So if you find one, you find the other. Okay. And then how much of each color do you need to make the kite in centimeters squared? So fabric is you're covering something, it's area. So what I do here is I find the area of the kite, I use the long diagonal, right? Long diagonal and the short diagonal. Right, I multiply these two, divided by 2, so that's the area of the whole kite. And obviously half of it is gray, half of it is white. Okay, so that's how I did that. If you're wondering how I got the long diagonal, it's not too complicated, right? 70 and 40 give you the 110, so you actually get the long diagonal there without having to use cosine law or sine law. Okay, so that's page 38. Then going to page 39, some classifying, right? So what is this top triangle here? Well, because that's ABC, right? ABC. Recall from the previous page, these are 45s here, back there, side by side. I know that these on the ends here are also 45s. But if you combine the 45s at the top here, you get a 90. And we do know if this is a kite, we know that these two angles are the same anyway. So we can just go ahead and say right isosceles for this one. Maybe I'll just say, right, this triangle here is what we're after. That's the one we're naming here. And that's the right isosceles that we're doing there. And then for the bottom one, it's going to be isosceles for sure because you know it's a kite, right? The question is it going to be acute or obtuse? Okay. And so I have this information from the previous page already, which allows me to find the third angle. It is almost equilateral, right? Like if we were to round everything to the nearest whole number, it would have been an equilateral, but if we just go by these numbers, then we have to conclude that it's an acute isosceles. Okay, so that's page 39 for you, explained. Let's keep going. Page 40 would have been done on a previous lesson, so that is already done. You can maybe just look at it, how I did that, and I'll just include it on this video. Page 41 would also have been done already on a previous video, so we'll just leave it at that. And then page 42, I'm going to just include that in this video as well, just in case. All right, so one change that you must make on this booklet, if it's not already changed for you, depending on what version booklet you're using, ZX, this is referring to ZX, which is this shorter diagonal here. Therefore, we know that each of these stretches are 1 centimeter. Okay, so what is it asking? The angle W, so that means, right, the whole thing, right? Measure of W, when it says it like that, is the whole thing, not just that perpendicular line here, or this stretch here does not affect the value of it. So we know that this being an isosceles is 1.5, 1.5, and this is 2, right? And I go ahead and just use cosine law, and I get 8362 for that, for this angle there. The measure of angle Y, which would be the bottom one. So again, you just cut out this piece, knowing that this is 3 as well. So 3, 3, and again, the short diagonal is 2. Okay. So we have cosine of Y, which is this angle here, right? And then make sure that the 2, which is across the angle you want, is subtracting at the end here. So we find that that's 0.77, keeps going, and that angle is 3894. Okay, 3894 for that one. I haven't used pink yet. So Y, which is right here, just right here at the bottom of this original kite, is 3894 there. Okay, and the other one was 8362. So we have that taken care of. So just gathering, just coming at it from different angles. And then next, the measure of YZX. So you got to be very specific here. YZX is this one, and WZX is this one. So it's almost like I'm splitting this one apart, right? I want, right, WZX, right, this angle. You can give it a letter, A, B, C, whatever isn't already being used. And this is the other angle, XZY. YZX, sorry. So YZX in this case, that's the green and the orange. So I'm using different highlighters there. So how did this come about? How did this angle come about? Well, if you recall, I got 8362 for angle W, right, for this whole thing. So you can split that in half and just get this sliver here. And that's where I get the 4181. And then you've got two angles. You can easily find the third, right? You just go 180 minus 90 minus 4181, and there you go. You have 4819 for that one. Same idea for the, so these kind of go together, right? They meet here. But this one, I take the angle Y that I found in B, I split that in half. That'd be step number 1. Same here, this would be step number 1, this would be step number 2. Okay, and then to find this angle, I'll just go 180 minus 90 minus this sliver, so I get 7053 there. Okay, so that's page 42. Let's keep going. Same, I'm still using the same shape as before. Just make sure this is ZX. That's the shorter diagonal. And what is it asking for? So WY, so once the long diagonal here. Yes, there are various ways of doing that, perhaps, but for me, I just know that this is 1.5 and this is 3. So I'm just going to focus on this triangle here and find it, right? So you can call this WY from end to end here. Okay. And so I actually know what this angle is here. I know what that is because I know both of these slivers, right? And so I get 118.72 for this one here for that angle. So I have a side angle side effectively, and that's how I find, I call it side Z here. I call that Z. Okay, so Z, I'm going to highlight that with this, and I find it right there, and it's 3.95 centimeters, almost 4. Okay. And then we'll do some classifying. So technically now you could find the area of this thing, right? You could go short diagonal, long diagonal, multiply that, divide it by 2, and voila, you've got the area. So it doesn't hurt, right? Next, you've got some classification. So YZX, so you're basically cutting and having this will be sort of the top, right? The top of the kite. I know you're like, this is sideways, but right, this is one isosceles triangle, this is the other one. So if we have it the right way, this would be right the top here. So they want to know, what is that? We know for sure it's an isosceles. We just have to see if it's obtuse or acute. And I already found these slivers earlier, right? I take them away from 180 to get 8362 here. So I can say acute isosceles. Then YZW triangle, right? YZW, it's this whole triangle. So we know it's scalene based on the side lengths, but this is 118.72. I already kind of figured that out earlier. So this is an obtuse scalene. Then XYZ is the bottom half, right? We know that these two are the same. And we know that these are 7053 from before. So I just take those away from 180 to get 3894. So it's also an acute isosceles. But it could be that one of these is actually obtuse, right? So you got to watch out for that, maybe both. So just use what you have, right? Fill in as much information as you can. Again, if you have all three angles, it's very easy to classify. Right? If you have all three sides, well, then you need to do a little bit of work to figure out, to kind of rule out the largest angle. Is it acute? Is it 90? Is it obtuse, right? So that's 43. Page 44, which is this right trapezoid here. They want to know side KL, basically, which is side X for me here, this stretch, and we find it, and it's 3.61, no problem. I just brought the 3 over to here, right? So you've got your right triangle going on. I use Pythagorean theorem, and I'm finding the hypotenuse. So you got to add your legs, right? Square them and add them. Then B, to find angle L and K. So again, I'm slicing out this one here and bringing it out. I just found this one. I rounded because that's what they wanted, right? So I'm using it here, rounded to 2 decimals. This is my pair. Okay, there you have your pair. What happened there? This is supposed to be 3.61. But I did fix it, so it should be fine. So sine of 90 over 3.61, sine of L, which is what they want, over 3. Okay, and that's 5620. 5620 is that angle they wanted. So I'm just going to highlight L here and underline that here and just go up to the top and just say I just found this one on the right trapezoid, right? I found that angle there. And you will recall that, right, on this side adds up to 180 and on this side adds up to 180. So that's actually given. And that's actually because the lines are parallel, right? When you have two lines are parallel, the angles in between those two always add up to 180. And so I'm using that property to find K, which is up here. And K is, don't be so worried about that dashed line. That's just there to help you figure out X, but K is in fact the whole thing. Okay, that's what they want. Otherwise, they would have used a different way to refer to just that sliver. So that's 123.80 there. So just go 180 minus the one I just found to get this angle here, right? Okay, 44, that's it. Keep going. A little bit of understanding here. So how can you make sure that the fence that is about to be built is parallel to the barn, right? So basically, you want this to be parallel to this, okay? And I don't know if you see the right trapezoid there, but one way to make sure that is happening is for these two angles on the sides here to add up to 180. So you make sure that there's a 60 here because these two then add up to 180, or this being a 90, you got to make sure you have another 90 there so that that adds up to 180. So that's basically what must happen, right? So make sure that the angles at the ends add up to 180. See diagram. So because of the diagram, I didn't need to do more explanation there. And what do we name this? It's a right trapezoid, right? So keep going. 46, all the way to 48. So we're going to do a little bit of exploring here again. So what's the perimeter of, so there it is. Perimeter is the distance around the parallelogram. So the parallelogram is this shape right here. Don't think that these two sides are part of it. Just tells you what the height is, and I guess this little sliver here. So what I did is I found x, right, using Pythagorean theorem because they meet at a 90 here. That's the assumption. So I get that, and x is that. So 2 times 8 plus 2 times the side I just found. Like, so these two sides added up and these two sides added up, right? If you add them all up, that's the perimeter. So perimeter P is just that. You should get 2321. What's the measure of angle ADC? ADC is right here. ADC, it's formed right here. And the next angle they want afterwards is this one, the orange one. So how do you do that? Well, watch this. Here you have to be careful, actually. So my only way to get information or an angle to appear here is to use this triangle again. So I use that, I take it here, and I know a lot of stuff already. I know that, right? I have a pair here. So watch what I'm going to do. I'm going to call this angle Y on this side. So angle Y is technically right here. If I find that, I can find this one because they are right next to each other. They're straight angles, okay? So I'm going to find Y. I find it to be 5361. I subtract it from 180 to get the 123.69. So this angle here, right? This angle here, which is the one I want, is found by using the straight angle property, okay? And then the measure of the top one here, this one, well, we know that they add up to 180, right? Anything stacked like that adds up to 180. So I do the same thing again, and so you'll notice that that angle shows up here again, okay? So you've got 46 taken care of, page 46. Then some sketching. I think I'll just briefly show you, right? So two properties that should be marked on it, and it's your whatever combination you want. Like, so two pairs of congruent angles and all four congruent sides, right? Diagonals are perpendicular, two pairs of parallel sides, and so forth, right? So you have your choices as to what you want to do. Some triangles. Obtuse equilateral does not exist because all angles are equal to 60. There's a kite here, so I'll give you some options. We keep going to 48. So assume this is a parallelogram, right? So parallelogram, two pairs of parallel sides. And we know something about this, right? If the 73 is here, we know that the one across from it is 73 as well. So that's the first one I solved. Then I know that these two add up to 180, so I actually did this one next. I just went 180 minus the 73, gave me the 107 up here. And so that allows me to say that this is 107, and these two are right next to each other. They add up to 180 as well, like they're touching. We call them adjacent, so that's my third angle there, 73. So you notice that 73 and 107 are the only two numbers that show up, and that's normal. And here you have to use that page that I showed you here where going up is always true, but going down is sometimes true. So you got to watch out for that. A square is always a parallelogram, right? So a square would be further down the flow chart. So yes, it will be a parallelogram because the parallelogram is above it. Every rectangle is also a square. That's not true, right? Because you would have rectangles. So parallelograms are kind of like the umbrella, and then you have a rectangle. A rectangle, and then from here you had your squares and your rhombi, right, or rhombus. So every rectangle is also a square, like every, that's the problem here. The word is always, and that's not true, so that's false. A rectangle is always a rhombus because we got a rhombus is a slanted square, right? And a rectangle is always that's not true. This rhombus can always be a rectangle, that's true, but not the other way around. A rhombus can never be a square. That is false. That is never. It could be. It could be a chance that it is. So the never is the problem there. That's it. And then we'll do polygons next. Thank you.